So far, we have seen the basic negative clamper circuit, unbiased as well as biased circuits, and in which I assumed the diode is ideal. If the diode is not ideal, then what will be the output? See this. If I take this basic negative clamper without reference voltage or unbiased case, I'm taking. Okay, first let me write without the resistor. Next we can use the resistor and continue it. Output. Suppose V gamma is given as the diode forward voltage. If V gamma is equal to 0.7 volt, maybe 0.6 or 0.7, whatever they give based on that video. Then what happens? How to analyze it? Input is the same 5 sin omega t. I'm just generalizing it. Okay, I'm taking some example. 5 sin omega t, the capacitor. Right. Now, what happens is if the diode is on, right, or we know during the first quarter cycle the diode conducts. Okay, 0 less than t less than t by 4, diode is on. Once the diode is on, the capacitor starts charging towards input, and what will be the voltage across the diode then? It is 0.7 volts and V input, V capacitor with polarities plus minus. Anyway, the diode conducts and the current flow will be this way. Okay, then what about V capacitor maximum? V cap maximum. Once the diode is on, the capacitor starts charging towards the voltage V in minus VD. Instead of V input, the capacitor starts charging towards value equal to V input minus 0.7 volt. So our V capacitor maximum is equal to Vm minus 0.7, or in this example 5 minus 0.7, 4.3 volts. Done. And for t greater than t by 4, we know the diode is off. Once the diode is off, then the diode acts as open circuit. V input is like some 5 sin omega t, and the capacitor voltage is 4.3. And what about V output? V output is equal to V in minus V capacitor. It is equal to 5 sin omega t minus 4.3 volts. Instead of 5, it is 4.3. Okay. Or what is V capacitor maximum? I wrote Vm minus 0.7. Or if I generalize it, it is like V input is Vm sin omega t minus V capacitor is Vm minus 0.7. So what do we get? Vm sin omega t minus Vm plus 0.7 volt. So if the diode is ideal, this is the output Vm sin omega t minus Vm. But if V gamma is given, then we just need to add 0.7. So as simple as that. Whatever, it need not be 5 sin omega t. Okay, whatever may be the input, just what we do, ideal case Vm sin omega t minus Vm, and if V gamma is given, just we need to add 0.7. Very simple logic, friends. What happens? See, V capacitor is equal to V in minus 0.7. Okay, we know that. And what we are doing? V output is equal to V in minus V capacitor. So that instead of minus, it becomes plus 0.7. That's it. We expect Vm sin omega t minus Vm, for which just we need to add 0.7 volts in case of negative clamper. Okay. Then what about the output waveform? It is Vm shift is minus Vm plus 0.7. Okay, this is how we can see the output waveform. Of course, in this example, it is -5 plus 0.7 volts. Steady state waveform. It is 0 at 0.7 volts. Instead of appearing exactly at 0 level, the positive peaks will appear with respect to 0.7 volts. All positive peaks, if you see, okay, they will be appearing with respect to 0.7 volts. V gamma. That's it. So what is the DC level of your output in this case? Means minus Vm plus 0.7. Generalized. The DC, what is the DC component present in the output? Means this is what we can take. Okay. This is the idea. If V gamma is right. The next one. Right, it need not be 5 sin omega t, it can be 3 plus 5 sin omega t or minus 4 plus 5 sin omega t. Anything is possible. The only thing is at the output, right? Capacitor, every time the capacitor voltage keeps on changing, and while rating the output voltage Vm sin omega t minus Vm plus 0.7 volts. That is the standard equation of the output as far as this negative clamper, unbiased negative clamper is concerned. Biased, just we need to add that reference voltage. That's it. So here, if I have, if the circuit is something like this, five sin omega t, it is something like some 2 volts like this. Capacitor V output. Okay, then what is V capacitor? In this example, I am directly writing V capacitor is equal to Vm minus 2 V reference. Along with that, I need to subtract 0.7. Okay, Vm minus 2.7 or 5 minus 2.7 in this example. 2.3 volts. And V output is equal to what we can write V in minus V capacitor. So it is equal to 5 sin omega t minus 2.3. Otherwise also, what we can write, or otherwise. So very simple. V output is equal to what we can write expected output or Vd plus reference voltage. What is Vd? What we expect, ideal case it is 5 sin omega t minus 5, but Vd 0.7 volts is considered. That voltage we need to add plus 2. However you take, you can see the same result. Ideal case response Vd is standard. Whatever may be the input may be 5 sin omega t or 2 plus 5 sin omega t or minus 4 plus 5 sin omega t. Anything is possible, right? Of course, here reference voltage is there. No, we should be careful. Accordingly, we have to see that for certain interval of time the diode is on. Once the diode is on, the capacitor will rapidly charge. Ultimately, the output Vd here is equal to 5 sin omega t minus 5 plus 0.7. This is Vd. This is Vd and it is V reference. Okay, so ultimately the final result is this. Conclusions. Look at the conclusions. Okay, and later we may have some resistor as well. Without resistor, I am showing. If you have resistor also, what we do, RC is very much large compared to the time period of the signal, and at least it should be 10 times. Time constant is 10 times the period of the input signal. Okay, that is the condition. I hope you get it. I'm not writing all the possible cases. We are well aware of it. Lot of discussion I made on negative clamper. The moment you see the circuit, just like that, you can make the output. Okay, for sine wave, these are all the things. If the input is a square wave, then what happens? I am taking square wave input. For example, it has a peak to peak amplitude of 10 volts, T by 2 T periods. This is passed through a basic negative clamper circuit. V capacitor is like this. V output polarities are this way. Okay. Then what happens? Here there is no quarter cycle. Here only we have half cycle. So during the first half cycle, that is from 0 to T by 2, the diode is on. Very simple. 0 less than T by 2, diode is on. Once the diode is on, the equivalent circuit is like this. What is V input? It is 5 volts. And current will be flowing like this. The capacitor will charge with polarities plus minus this way. And V output. Here also V input is equal to V capacitor plus Vd. And neglecting Vd, V capacitor is almost equal to V input. Or strictly speaking, the capacitor will rapidly charge towards, not abruptly. Input is having abrupt rise, but the capacitor will rapidly charge towards input voltage. So, if you take V capacitor, the capacitor will rapidly charge towards input voltage. Like this. It's like some kind of step response. Okay, if you apply a step signal to a low pass filter, what happens? The capacitor will rapidly charge. Even okay. So up to here. So before T is equal to T by 2 only, the capacitor reaches charges up to 5 volts. No doubt about it. Not like sine wave and all. Right here, the capacitor is charging up to 5 volts before T is equal to T by 2. No doubt about it. So now how to analyze it? At T is equal to T by 2 minus V input is equal to 5 volts and V capacitor is also equal to 5 volt. No doubt. Done. During that time, what is our output? Output is almost equal to 0. Right. At T is equal to T by 2 plus. What is V input? V input falls from plus 5 volts to minus 5 volts. So instantaneously voltage across the capacitor cannot change its value. So what is the capacitor voltage? But V cap remains at plus 5 volts only. Then what about V output? V output is equal to V in minus V capacitor. It is V input is minus 5, V capacitor is 5. So ultimately the final result is minus 10 volt. So here there is an abrupt change in input, but the capacitor is not responding for abrupt changes. So whatever the change you have in input, that should appear across the output terminals, because we know the equation V input is equal to V capacitor plus V output. So input, there is an abrupt change here and there is no change here. So whatever the changes you have here, all changes can be seen across the output terminals. Absolutely, across the diode you can see. So which means output is minus 10 volts, which is negative. Vd is negative. This is nothing but our Vd. As Vd is negative, what happens to the diode? Immediately the diode becomes off. or I will write it in the next page. So as VD is negative immediately, which implies the diode becomes off. Once the diode is off, the equivalent circuit is this way. This is V input and the capacitor voltage is 5 volts with polarities this way, and V output are VD. Once the diode is off, there is no path for the capacitor to charge further or discharge the voltage it has acquired. So the capacitor can neither charge nor discharge. We know it simply acts as a battery. Then what is our output? V output is equal to V in minus V capacitor, and V in minus V capacitor is nothing but V maximum, V input maximum. Is it not so? The maximum value of input. In this example, right, anyway, V in minus 5. Right. So that's what we can see here. V input is anyway minus 5, and it is capacitor voltage remains constant at 5 volts. We'll see. Anyway, T by 2 to T, what is happening? Input is negative, capacitor is positive, V input minus V capacitor, output is negative. Done. Again, the input is, so this is what we can see from T by 2 to T. Okay. Or we can even take like this, T by 2 plus and okay. So above circuit follows. Above circuit is valid from T by 2 to T. T by 2 less than T less than T. Okay. Then at T is equal to T minus, V input is minus 5, V capacitor is equal to plus 5, and output is equal to minus 10 volts. Everything is fine. Now at T is equal to T plus, what is happening? Input is rising from minus 5 to plus 5. But the capacitor voltage cannot change instantaneously, and V capacitor at T is equal to T plus is equal to V capacitor at T is equal to T minus. Ultimately, its value is 5 volts. Then what about the output? Implies V output is V in minus V capacitor as usual, 5 minus 5, 0 volts. See, here input is abruptly rising. Anyway, here it is minus 5, the same. So ultimately it is minus 10. Now at T is equal to capital T, the input is abruptly rising by 10 volts. And the capacitor is unable to change its value, capacitor voltage. So whatever the rise you have in input, that rise can be seen across the output only. Output also rises by 10 volts. Input is rising from minus 5 to plus 5. Output also rises from minus 10 to 0. Same amount remains the same. So what is the output now? It is 0. Is it not so? And V capacitor remains 5. And for 0, still the diode remains in off. For the diode to on, the input voltage should be positive, more than 0. But our input maximum is 5, and hence output maximum will be 0. As long as it is 0, the diode does not contact. And the capacitor holds the 5 volts as usual. After that, for t greater than, right, at 3t by 2, you can see what is happening. At minus 3t by 2 minus, input is 5, output is V capacitor is 5, output is 0. At t is equal to 3t by 2 plus, input is abruptly falling by 5 and the capacitor cannot change its value instantaneously. So the output falls by the same amount. That's it. Next, input is minus 5, V capacitor is 5. Output is V in minus V capacitor minus 10. So the next cycle, again there is an abrupt rise in input. Capacitor voltage does not change. At that time, output will also abruptly rise. So this is how we can see. Sine wave or square wave, is there any change in the shape of the output? No. Output wave shape remains the same. But the only difference is input, the average value of input or the DC component of input is 0. And what is the DC component of output? Minus 5. That's it. Input is pure AC. Output is equal to input minus V capacitor. V capacitor is input maximum. Right? That becomes the DC component of our output. Okay. This is how we can do this problem. And one more thing, right? That's the idea here. Right? I need not write for various cycles. I hope you all understand. The next point is the input is something like this, like what we did in sine wave. Just I'm taking some possible cases. Means it is not appearing with respect to 0 volts. It may be some 7 volts and it is something like minus 3 volts. Then what is the output? What is V capacitor? Here, this is passed through our basic clamper circuit, negative clamper, unbiased clamper. Then V capacitor maximum. V capacitor is equal to V input maximum value of input. What is this? 7 volts. The diode will be on from 0 to T by 2. So that the capacitor will charge up to 7 volts rapidly. Then what about V output? It is V in minus V capacitor. It is V in minus 7. V in minus 7 we can take. I'm writing the steady state results. So capacitor voltage is 7. Capacitor will charge up to 7 here rapidly. Later it remains constant. What about V output? 7 minus 7, it is 0. Next, here it is minus 3 minus 7 minus 10. The result does not change. Like what we studied for sine wave. V output. Sorry, it's not V output, it is V capacitor. No? V capacitor is like this and V output is this way. That's it. If you have reference voltage, we know the signal will further move up or down by an amount of the reference voltage. If reference voltage is positive, the overall output will go up by an amount V reference. If reference voltage is negative, it further falls down by an amount of reference voltage. And the reference voltage should be chosen in such a way that there is a scope for diode to be forward biased over certain interval. Otherwise, you won't get the output. Output will be equal to input. Okay. Right. And here also, if V gamma is given. Okay, I will write that case also. Right. Just I am taking the next case. input may be this way, or 7 volts input -3. Okay, input 1 or input 2 or input 3. Just I'm taking some cases. It is 2 volts -8 volt. All these 3 cases, and these are passed through our clamper circuit, negative clamper, with a reference voltage of 1 volt. Then what is the output? Okay, see, V input maximum minus V reference, if you see, that should be positive. That's it. So here 5 minus 1, 4 volts. In the first, for one first input, the capacitor will charge up to 4 volts. In the second case, the capacitor will charge up to 7 minus 1, 6 volts. Third case, the capacitor will charge up to 1 volt. Is it not so? And what about V output? Okay. Output is equal to input minus V capacitor. So, input minus 5. Anyway, output will be, oh, sorry, yes, V input minus V capacitor. So, if V input 1 is equal to, right, for V input 1, let me write that way. With respect to input 1, V capacitor is equal to 5 minus 1, 4 volt. Okay. And V output is equal to input minus 4. With respect to V input 2, V capacitor is equal to 7 minus 1, 6 volts. And V output is equal to V input minus 6. And with respect to input 3, V capacitor is equal to 2 minus 1, it is 1 volt. And hence V output is equal to V in minus 1. In any case, you see here 5 minus 4, output maximum is 1 and output minimum is equal to minus 5 minus 4 minus 9. So what you can see, 1 to minus 9. Second case also, it is 7 minus 6. 7 minus 6, 1 volt. Output maximum is 1. Output minimum is equal to minus 3, minus 6, minus 9. Right. Third case, 2 minus 1, 1. When input is maximum, that time corresponding output. And input is minimum, minus 8. The corresponding output is minus 8, minus 1, minus 9. So, in all these 3 cases, the capacitor voltage will change. But we know what is VD blindly. And for VD, we are adding 1 volt. Is it not so? Whether it's sine wave or square wave, the approach is same. Okay. So, in all the 3 cases, our output is this way. 1 volt, 0 volt and minus 9 volt. That's it. Next, if V gamma is given, we are well aware of it. Okay. If V gamma is equal to 0.7 volt, then V output is equal to V in minus V capacitor plus 0.7 volts. Blindly we can write it. Okay, that's it. I'm not showing the waveforms. That if you want, you can take it. Unbiased clamper means, okay, write some square wave input to this unbiased clamper. Then how do we get the output here? It's plus 0.7 now. 0.7 is added. 0.7 volt, and it is equal to, right here, peak to peak amplitude. Suppose it is, just as an example I am writing, it is 10, then this is also 10. It is minus 10 plus 0.7 volt. Like this, we can take the result. Okay, with reference, right? It is unbiased and biased, means using some DC power supply. VR square wave input. What do we get? Similar waveform, but it goes up by an amount of V reference. It is 0.7 plus VR, V reference, something 0. It is like minus 10 plus 0.7 plus VR. If input has a peak to peak amplitude of 10, this is over. Okay, this is how we can analyze the negative clamper circuits. I'm not showing the, here I have not shown the resistors. You can even write the resistors also, not an issue. That's it. Okay, then let us have a look at the positive clamper. Unbiased clamper, first we will see. Next, biased clamper. I wrote here the final statement, output is equal to input minus V input negative peak. Earlier, I wrote V output is equal to input minus V input positive peak. Now it is negative peak. How it is seen? Anyway, this is how we can see the output waveform for an input. Suppose input is like some 5 sine omega t, can be anything. Just as an example, I wrote it. Then it is plus 10 volts and it is 5 volt. Okay, what is about this one, etc. Just we need to see. Okay, let us take the analysis of positive unbiased clamper. Positive clamper means signal is pushed up now, diode should be directed upwards. V input, I am just taking as usual V capacitor polarities, V input polarities, and V output or VD polarities. VD polarities means bottom to top. Output polarities means top to bottom. It is equal to minus VD I am writing. VD, diode voltage, is always from anode to cathode. That's my notation here. Okay. Then this is VD. Okay. Here, let us take the waveforms. T by 2, 3T by 4, T, 5T by 4, 3T by 2. This is enough for us, more than enough. V capacitor, V output, R minus VD. Okay. So first let us start with T is equal to 0. At T is equal to 0 or 0 plus, V input is 0. Assuming 0 initial conditions, V capacitor is also 0. What happens to the diode? The diode does not conduct. Okay. T is equal to 0 plus, I am speaking. Input is positive, means the cathode of the diode is going towards the positive terminal of the supply and anode is going to negative terminal. So diode does not conduct as long as my input is positive, right? During the first half cycle, not quarter cycle, first half cycle, first positive half cycle. That is, anyway, we know that here V input is equal to, as usual, V capacitor plus V output. Please be observe, right? Be careful here. And V output is equal to minus VD. The diode voltage is from anode to cathode, but the output is from top to bottom. Okay, we know that. Done. Next, due to initial, with 0 initial conditions, V capacitor is equal to 0 at T is equal to 0. Okay, done. Next, let us take over the first half cycle I am taking, 0 to T by 2. Input is positive. As input is positive, the diode cannot conduct because the cathode is connected to the positive terminal of the supply and anode is connected to the negative terminal of the supply. Diode is off. As the diode is off, there is no path for the, okay, diode acts as open circuit. So, is there any path for the capacitor to charge or discharge? Nothing. Simply, it acts as short circuit. There is no possibility for the capacitor to charge. So, what is V output? Output is equal to V capacitor is 0 and output is equal to input. Like this. Right. Next, take the first negative quarter cycle, that is T by 2 to 3T by 4. T by 2 less than T less than 3T by 4. During this interval, if you take the circuit, see here negative cycle, it is like connecting a negative source. Then what happens? The cathode is connected to the negative terminal and anode is connected to the positive terminal of the source. As the input is negative, I am saying it appears like cathode is connected to the negative terminal and anode is connected to the positive. Diode starts conducting. Diode is on. Once the diode is on, the equivalent circuit is like this. Ideally short circuit, practically we can replace the diode by means of its forward resistance and input. How does the current flow, friends? Here the current flows from always anode to cathode. Even though the input is like this, it is a negative cycle. No? Okay, it's like connecting a negative source. So positive to negative terminal, the current will be flowing. Here V capacitor polarities do not change. And output polarities also do not change. But the current is going in this direction, so that the capacitor will charge with polarities this way, plus minus. Current always flows from positive to negative terminal. As it is a negative cycle, I am showing the polarities this way. It looks like some negative source is connected. That's the meaning of it. And the capacitor, diode is on means the current, once the diode is on, current always flows from anode to cathode. So anti-clockwise direction, we can see the current flow. In this, as usual, our regular equations, right? These are why I showed all these polarities, means to say that once the diode is on, current flows from anode to cathode, and so that the capacitor will charge from right to left, not from left to right. Just to make you aware of that, I am showing all these things. But if you take your as KVL, KCL, etc., as usual, V input is equal to, don't look at the polarities and take the equation V input is equal to V capacitor plus V output. That is the universal statement here. So as far as the circuit is concerned, we know V input is always equal to V capacitor plus V output. Okay. And when does the diode conduct and how the capacitor charges means, this is the idea. Right, and V input is equal to V capacitor plus V output. And V output, the capacitor will rapidly charge towards input with a time constant RF into C. Okay, so that in this equation, V input is equal to V capacitor plus V output. I am not writing VD, here I am writing only V output. V output is equal to minus VD, it is negligible. So V capacitor is approximately equal to V, approximately. Rapidly it is charging. Right? This is what we can write. Done. So if I take this waveforms, V capacitor, whatever the shape you have for input, the entire thing can be seen across the capacitor. And V output is 0, assuming ideal diode almost. V in is equal to V input is equal to V capacitor plus V output, in which V output is almost 0, and whatever the input you have, that is seen across the capacitor. Means the capacitor voltage is now negative. Yes. What is V capacitor? V capacitor polarities I took from plus minus, but it is charging from right to left. Is it not so? So V capacitor is negative. No doubt about it. Input is negative, V cap is also negative. Done. Next, at T is equal to 3T by 2 minus V input falls up to its negative peak of minus 5 volt. Okay. The input is just reaching its negative peak. By that time, anyway, almost the capacitor voltage reaches minus 5, but due to small delay, it is not exactly minus 5, it may be minus 4.9. and due to small delay, V capacitor is not exactly equal to -5, it is minus 4.9 volt. Okay. Further, at t is equal to 3t by 2 plus, the input now rises above -5. Input has come down to its negative peak. Next, what happens? Okay, input is coming down up to -5. After that, it will rise. Right? By that time, the capacitor reaches -5 volt. V input just rises above -5, that is minus 4.9 volt, and V capacitor by that time reaches -5 volt. The concept, story, everything is same. Instead of taking positive quarter cycle, I am taking here negative quarter cycle, which implies V output is equal to V input minus V capacitor. It is minus 4.9 minus V capacitor is minus 5. Ultimately, it is equal to plus 0.1 volt. And of course, what is VD? VD is equal to minus V output, no? As I mentioned. So, but we know VD is equal to minus V output, that is minus 0.1 volt. VD means anode to cathode voltage is negative. Here what we can see, V output is taken from cathode to anode. So cathode to anode voltage is positive, means anode to cathode voltage is negative. Immediately the diode becomes off. Once the diode is off, this is the equivalent circuit. The capacitor has charged up to 5 volts with polarities. This. Okay. It is anyway. V capacitor polarities are like this. So V capacitor is -5. Once the diode is off, the capacitor can neither charge nor discharge. Implies the capacitor can neither charge nor discharge. Simply it acts as a DC source or battery and maintains that -5 volts across it forever. Earlier, the capacitor has charged up to positive peak. Now the capacitor charges up to negative peak. It is -5. It is just nothing but the negative peak. But is the input keeping quiet? No, it is doing its duty. It is sinusoidally varying, but the capacitor is not responding as the diode is off. So whatever the variations you have in input, those can be seen across the output terminals. Or I can even write further like this. So V output is equal to V input minus V capacitor. Input is 5 sine omega t and V capacitor is minus 5. So output is 5 sine omega t plus 5. It looks like you are adding plus 5 volts to 5 sine omega t. Equation wise. Let us see here what happens. Here the input is rising from this point to this point, 3t by 4 to t. Input is rising by 5. Capacitor voltage is constant, so output also rises by 5. So at t is equal to capital T, output is equal to input minus V capacitor. That is, input is 0, minus of minus 5, it is plus 5. Again from t to 5t by 4, input is rising further by 5, V capacitor is constant. So output is equal to, at t 5t by 4, it is 5 minus of minus 5, it will go up to 10 volts. So how much amount is the rise from 3t by 4 to 5t by 4? Input is rising by 10. Output also rises by 10. Okay, output is positive, means VD is negative. As long as VD is negative, diode cannot continue. If you want, we can write that also. So at t is equal to negative quarter cycle, no, 3t by 2, right? Okay. At t, V output is equal to, at t is at the end of one half cycle, right? One cycle, full cycle, input is 0. Capacitor voltage is minus 5. 0 minus of minus 5 plus 5 volt. 5t by 4. Output is equal to, input reaches its peak amplitude. Capacitor voltage is minus 5. So 5 minus of minus 5 plus 10. Next, if you want, we can write it. 3t by 2. Output is equal to, t is equal to 3t by 2. Input amplitude will be minus 5. And capacitor voltage is minus 5 minus of minus. Sorry. 3t by 2, no? Next we have to see 3t by 2, not 3t by 4. 3t by 2. Input is falling by 5. Output also falls by 5. Next, 3t by 2, I should write there. 3t by 2. Input is 0. Sorry. 5t by 4, 3t by 2. 5, 10 G, right? 10 to, again it was falling up to 5. Next, at t is equal to 7t by 4. Output is equal to, right? Again, output falls from 0 to minus 5. So minus 5 plus 5, it is 0 volts. Now it's proper. It is, right, 7t by 4. Output becomes 0. Very next, what happens? It is 2t. At t is equal to 2t. Okay, here it is falling by 5. It is not responding, and that fall we are observing here. Next, 7t by 4 to 2t. Input is rising by 5. V capacitor remains constant at minus 5. So output will rise by 5. Next, right? So here what happens? Your output is not able to become negative. Output is always positive, means VD is always negative. VD is always negative means the diode cannot conduct and the capacitor voltage cannot change. It remains constant at minus 5. Output is equal to input minus of minus 5, that is input plus 5. It looks like we added a positive DC to the given input without using any external battery. So again, input is rising further by 5, output also rises by 5. Next, input is further falling and output is also falling. When input falls to its negative peak, that time output can come down to 0. This is how we can see the response. So, are you not getting a response of this kind? Anyway, right, we can take this portion as transient. Removing this transient in steady state, this is output equation, 5 sin omega t plus 5. in steady state, V output plus 10 volts, 0 volts time axis. So it looks like 5 plus 5 sine omega t. So what we can understand, as it is looking like we added some positive DC to the given input, it is called positive clamper or negative peak clamper. Hence the circuit is named as called positive clamper or negative peak clamper. Negative peaks are clamped to the ground. Okay, and here what happens to V capacitor? The capacitor always charges to input negative peak. In negative clamper, capacitor charged up to positive peak. Here the capacitor will charge up to the negative peak of the input. Okay, here the capacitor charges up to V input minimum or V input negative peak. That's it. So if you have, based on that, see this, suppose my input is like means my input is like minus 3 plus 5 sine omega t. So to what level the capacitor will charge then? V capacitor is equal to minus 8. Is it not so? This is passed through our positive clamper. Then what about V capacitor? In this example, V capacitor is equal to minus 8 volts. So V output is equal to V in minus V capacitor. What is V capacitor? It is V input negative peak or V input minimum. It is equal to, right, input is minus 3 plus 5 sine omega t minus of minus 8. It is equal to 5 plus 5 sine omega t. Unbiased, no? Unbiased clamper means negative clamper, the output is minus 5 plus 5 sine omega t. In positive clamper, the output is 5 plus 5 sine omega t. Very simple. The output wave shape does not change. Okay. This is what we can take. Instead of that, if the input is four volts, something like this, it is 4 plus 5 sine omega t. So what is V input minimum? This is passed through our positive clamper. Don't worry about the duration in which the capacitor charges, etc. Right? What happens in the steady state? The capacitor will charge up to V capacitor is equal to V input minimum or V input negative peak once the diode is on. So it is minus 1 volt. So diode is upwards now. At least it should be, the diode should experience positive voltage or output should be some negative value. Then only the diode will conduct and a capacitor will rapidly charge up to the negative. And V output is equal to V input minus V capacitor. So what is V input? Here 4 plus 5 sin omega t minus V capacitor is minus 1. It is 5 plus 5 sin omega t. Are you not getting? Unbiased. Every time the capacitor voltage only changes, the output equation does not change. It remains as usual. 5 plus 5 sin. Okay. Like this we can take. Next one. If reference voltage is present, what happens? Biased positive clamper, right, or biased positive clamper. It can be positive or negative with conditions, right? And input is some 5 sin omega t. I am taking. Okay. Suppose it is 4 volts. I kept. Then what is V capacitor? When does the diode conduct? During a negative cycle. And V capacitor is equal to what level the capacitor can charge? Input minimum minus this. Is it not so? Okay. So once the diode is on, the capacitor voltage V capacitor is equal to minus of, I can write V input minimum minus V reference. Minus V input minimum is minus 5. Okay, plus I should take, sorry. Here minus 5 plus 4, it is equal to just wait. If I write directly, it's a problem. Okay, once diode is on, then what is our equivalent circuit? Of course, it will, right? This is the capacitor. Diode almost acts as short circuit, and it is some 4 volts input. So how the current will be flowing? This way, and I can take the polarities like this. What about the capacitor voltage? Anyway, it is having polarities like this. Okay, just to show how the capacitor is charging. But we know the original input has polarities from top to bottom. We know V capacitor is equal to, or V input is equal to V capacitor plus Vd plus Vr. And neglecting Vd, V capacitor is equal to V input minus V reference. We know. Okay, so again, what happens here? V input is equal to, right, V capacitor in steady state. V capacitor steady state I am writing. V capacitor steady state. How much it is? V input minimum minus V reference. V input minimum is minus 4. Okay. And VR is, sorry, V input minimum is minus 5 and minus 4. It is equal to minus 9. The capacitor will charge up to minus 9 volt. Okay, this is the idea. Once the capacitor is charging up to minus 9, then once the diode is off, then V output is equal to V input minus V capacitor. V input is 5 sin omega t minus V capacitor is minus 9. So it is 9 plus 5 sin omega t. Is it not so? Okay. Or alternatively, V output is equal to, right, I can say it is Vd with polarities minus plus. So minus Vd plus 4. What is minus Vd? Earlier we have seen. Here V output is equal to, it is 5 plus 5 sin omega t, which can also be taken as minus Vd. Is it not so? Okay. So I mentioned here V output is equal to minus Vd. V output is equal to minus Vd. What is V output in steady state? 5 sin omega t plus 5. So Vd is minus of 5 sin omega t. So in that way also we can take minus Vd value is 5 sin omega t plus 5 plus 4. Just we are adding the reference voltage. Are you not getting the same answer? 9 plus 5 sin omega t. Simply what we do, without a biasing or without a 4 volts reference voltage, we know the output equation 5 sin omega t plus 5, for which we need to add this reference voltage of 4. That's it. Blindly we can do it. I need not do all such analysis. Just for the for better understanding, I am doing it so that the students can think in different ways. But the moment you see the circuit, whether it's a negative clamper or positive clamper, what we can write is diode voltage we know. Okay, for that we need to add the reference voltage. That's it. Okay, so this is the idea. Again, next we can even take another circuit like this, same positive clamper, and I may connect here some negative voltage. It is 5 sin omega t. So what is V output? V output is equal to minus Vd minus 3. Minus Vd value is positive, means Vd is negative. Okay, that's what you should think of. 5 sin omega t plus 5 minus 3. Ultimately, what we get? 2 plus 5 sin. That's it. And to what level the capacitor will charge? The capacitor will charge up to, okay, yes, V capacitor is equal to V input minimum I wrote earlier. Okay, and from that we need to subtract this minus 3 volts. Is it not so? See here what I wrote, V capacitor is equal to V in minus V reference. Okay, we can take that also, not an issue. So V input minimum is minus 5, minus V reference is minus 3. So it is equal to minus 2 volts. Absolutely. We are getting. Okay. I need not write these many combinations, right? Just students can easily understand it. V input minus V capacitor, it is 5 sin omega t minus of minus 2. It is 2 plus 5 sin. If I discuss more unnecessary confusions, of course, possible. That's it. With reference voltage, you may have positive or negative reference. This is the story. Whether right, I'm not changing these statements. V capacitor is equal to, right, in negative clamper V input maximum minus V reference. Here it is V input minus V input minimum minus V reference. That's it. There is no much difference. Just like that we can take it. Okay. And practical clamper circuit means, right, unbiased. How does it appear? There is some resistor RC, V input, and output. RC should be far greater than time period, or RC should be at least equal to 10 times time period. With reference voltage, unbiased is done, and biased means this one. V reference, V input. So V output is equal to generalized equation. Vm sin omega t plus Vm is expected. Here also Vm sin omega t plus Vm expected. And for that we need to add this V reference. VR. That's it. Of course, I'm writing this resistor. Okay, if V gamma is given, then what happens? If V gamma is equal to 0.7, in negative clamper, we added 0.7 volts at the output. Now what we need to do? Subtract. Exactly opposite action. Nothing else. Or once the diode is on, the capacitor will charge up to minus V in plus 0.7. That's it. Okay. V input, V output. Once the diode is on, V capacitor is equal to V input minimum plus 0.7. That's what. So it is minus 5 plus 0.7 if V input is 5 sin omega t. It is equal to minus 4.3. Then V output is equal to V input minus V capacitor. It is 5 sin omega t minus of minus 4.3. 5 sin omega t plus 4.3. Means what does it mean? The expected output is ideal case 5 sin omega t plus 5. But what you are doing? You are subtracting V gamma in positive clamp. Okay. We need to add 0.7 to V capacitor, or we need to subtract 0.7 from the output. That's it. And input need not be sine wave, it can be square wave also. So, okay, in this case, what we can write? The output in steady state. Instead of 5, it comes with respect to 4.7 volt. Negative peaks, instead of appearing with respect to 0 volts, they appear with respect to 0.7. Output maximum is equal to 9.3. Peak to peak amplitude remains as 10 volts only. Okay, peak to peak amplitude does not change. That remains as usual. That's it. Okay. And one more thing, as I told, all right, input can be 5 sin omega t or 3 plus 5 sin omega t or minus 4 plus 5 sin omega t, different combinations you can see. Ultimately, the diode should experience some positive voltage to conduct for input negative peak. Then we can take V capacitor is equal to input minimum plus 0.7 and accordingly now. Doesn't matter, we know the standard outputs. These are all right for understanding sake only, but we know ideal output what comes, what we need to add, whether we need to add or subtract 0.7. Negative clamper you are adding, obviously in positive clamper we need to subtract. That's it. If you remember one case, the opposite action for the next case. That's it. With V reference, what happens? Again, here 9.3 plus VR and here